हेलो एवरीवन, इन दिस वीडियो वी विल बी लर्निंग टोटल डिफरेंशिएशन। अब तक तो हमने देखा था रेगुलर डिफरेंशिएशन क्या होता है, पार्शियल डिफरेंशिएशन क्या होता है। नाउ वी विल बी लर्निंग टोटल डिफरेंशिएशन। सो दिस इज one more new type which we will be learning. So what is this? What will be this? We will just look it here. So यहाँ तक हमने देखा था प्रीवियस इन द वट एवर वी हैव लर्न डिफरेंशिएशन पार्शियल डिफरेंशिएशन में, लाइक इट यूज टू बी फंक्शन ऑफ एफ ऑफ एक्स एंड वाई। लेकिन यहाँ पे कुछ लिटिल बिट इट्स फर्दर मोर इंफॉर्मेशन इज देयर. U is a function of x and y, and x and y are again the function of third variable, like x and y are further function of t. Like here I have put it, x is a function of t and y is also function of t. Then if you want to find the differentiation of u with respect to t, like I will draw it here diagram so it will be easy to understand. U is a function of x and y, and what we are saying, x and y are further function of t. This is how it is. So if I want to differentiate this u with respect to this variable which is independent or which is indirectly related, what I would say, u is not directly related to t but it is indirectly related to t. So if you want to find the differentiation of u with respect to t, which is indirectly it is connected, that type of differentiation we call it as total differentiation. So if you see here, u is related to t indirectly through x and y. So whenever you will be finding differentiation of one variable which is indirectly related, that time we will call it as a total differentiation. And how we find it, there is a formula for it, which is now here we are finding differentiation of u with respect to t. So du by dt, which is equal to del u by del x into dx by dt plus del u by del y into dy by dt. So if you look here, this is here first term is written in terms of del, next term is written in terms of d, again here it in terms of del, and here it is in terms of d. So it is understanding this will be better if you want to remember it properly or correctly. So how we write it here, since u is a function of two variables, whenever a function is of two variables, it means more than one variable, that time we use it del. Partial differentiation we do it. So that's why, since here if I want to reach from u to t, what I will do it, I will go from u to x and then from x to t. So that's why we have written first del u by del x and then del dx by dt, because from here to here u to x, that is del u by del x. Why del? Because u is function of x and y, it's more than one variable, so that's why we are using del. Still we have to reach to t, so that's from one more dx to dt. Since x is just function of one variable which is t, that's why we can write it dx by dt. So that's how we reach from u to t. This is the one way. Now this next term is how you can reach from u to t. So first of all, you will go from u to y, and since u is a function of x and y, two variables, we will be using del. So here I wrote it del u by del y. Still we have to go further to t, from y to t. So, and since y is just function of one variable which is t, that's why I have wrote it here dy by dt. That's how we reach from u to t. So this is the way you can remember it. Remember that when function it's of more than one variable, that time you will be using del operator, like here I use del u by del x and here also del u by del y. When it's a function of one variable, like x and y are just function of one variable which is t, that time we just use dx differentiation, regular differentiation we do it. Now here also if you look at the left hand side, here du, I have used du because u is a function of xy, that is how it is given over here. But if you look at x and y are further function of just t variable. So instead of this xy, I can replace this xy in terms of t also. So if I replace this function with t, so then u will be just a function of one variable, which is t. And since it's a function of one variable, I have used here in the left hand side also du by dt. So that concept of where to use regular differentiation, which is denoted by d, and where to use partial differentiation, which is denoted by del operator, that should be clear, so that you will not get confused with it, because most of the student gets confused with here where to use del and where to use d. So make it that understanding very clearly. So this is the differentiation, the total differentiation definition part, and that's the formula and how you can remember it or remember it better way. So now, so far we have learned different types: regular differentiation, then partial differentiation, and then total differentiation. So if you want to take the overall look of all these three types for better understanding and to understand what's the difference in these three different types, so that there won't be any confusion or we shouldn't be mix them with each other. So I have put it in one table format to make it easy to understand. So first, in the first column here I have put a differentiation like a regular differentiation, where we use two variables x and y, and most of the time this y used to be dependent variable and which was dependent on x, and x was independent. This was the normal situation, and this is dependent. Okay. So in that case, the case was simple, we just find a dy by dx, and double differentiation is also, which is second order equation differentiation also we call it, that's del square y upon del x square. Now in the second column what I have written is here partial differentiation, where the x and y are two. In partial differentiation what we do it, we consider the variables independent, means they are not dependent on each other. And in partial differentiation we differentiate with respect to one variable, that time we consider other independent variable as a constant. So that's the thing. So for example, with respect to x, if I will differentiate partially, y will be constant, and if I differentiate with respect to y, x will be constant. So that's why we write it in this way, del z by del x and del z by del y, and this is second order partial differentiation. So this is the concept with the partial differentiation, when variables were treated as independent. Now in the total differentiation, what is the concept is, one function is related to variable, and like u is a function of x and y, and x and y are further function of other variable. So they are other functions of other variable, and we have to find the differentiation of y with respect to t, means we have to find the differentiation with respect to variable which is indirectly connected, not directly but indirectly connected. So that is nothing but the total differentiation. Formula how to find it, that we have seen just in the previous slide. So now this is hopefully this what is the difference and how we treat the variables separate different way, that is clear for you. So far we have learned the concept. Now in the next video we will be solving university based questions.